Good morning, students. How are you? I hope you all are doing well and are ready for today's class. So in today's class, we will be discussing on the applications of SOHCAHTOA, the three main angles that we learned last week. So in today's class, our main objective is to apply the application of SOHCAHTOA, calculate the right angle triangle calculate the right angle triangles on one side, and finally find the unknown angle of that right angle triangle. So just a basic recap from the last week class. Last week we learned about Pythagoras theorem. So students, the Pythagoras theorem is a squared plus b squared is equals to c squared. That we learned last week. And the other thing we learned last week was the trigonometric function, which is SOHCAHTOA. We just learned about brief. So in today's class, we will be using those applications to find the unknown side and the angle of a triangle. And also, we also learned that the names of the sides of the right angle triangle. So for this application, we will be focusing on the right angle triangle only. So we all know that the right angle triangle has the angle of 90 degrees and the two theta's. Opposite of the theta, we have this side is called opposite, which is also can be labeled as A. Opposite of the angle of 90 degrees, we have hypotenuse, which can be labeled as C. And then the angle, the side that has both 90 degrees and the theta angle, we can call that adjacent, which is B. So as you can see over here, this is the graph. This is a right angle triangle. We have the angle 90 degrees and the theta. So opposite of the theta is the opposite side, we label as A. The angle, the side that has 90 degrees and the theta, which is B, that is our adjacent, and opposite the 90 degrees angle is our hypotenuse. So now we'll come back to our three main equations that we learned last week, the sine, cos, and tangent graph. So as we all know, the main from the main three, in short, the SOHCAHTOA that is there, S, O, H, so, K, and O. We can see that the equation that is written there will be coming from these names. The OH from So, the AH from Ka, and P, the OA from Tor. So, as you can see that sine theta is equal to opposite over hypotenuse. So in short, we can just write sine theta is equal to opposite over hypotenuse. So that's why we say so. Then coming to cos theta is equal to 8 over h, which is our adjacent side and the hypotenuse side. And then finally the last one, tangent theta is equals to O over A, which is our opposite side and the adjacent side. So these three main equations, we will use it more to find the unknown side and the angle. So there is a short note here. It says sine theta divided by cos theta is equals to tangent theta. So always remember that. Next slide. So now we will move to the example 1. So the example says that find the length of the side marked x in the right angle triangle given below. So we have a right angle triangle here, and we are given the information x that we have to find 3, and we have given the theta value, which is 55 degrees. And we all know that the right angle triangle has a 90 degrees angle. So we have learned that opposite of the 90 degrees angle is our hypotenuse. Hypotenuse. And we have so this is our h, and opposite of the theta value is our opposite O. So going back to the main equation, so we can see we are given with O and H. So looking at the three equations, we can use the sine theta equation. So our sine theta equation is sine theta is equals to opposite over hypotenuse. Then we have sine, we have the theta as 55, and we know our opposite is 3. So we will write 3 over h, and we know that h is our x. So now we are going to solve for x. We'll multiply x this side to our left hand side, then it will be x sine 55 equals to 3. Making the x of the subject of the formula, we'll divide it by sine 55. So x sine 55 divided by sine 55 is equals to 3 divided by sine 55. Sine 55 cancels here. So we have x is equals to 3 over sine 55. Now take out your calculators. So now we can use this. Make sure your calculator is on the degree mode, not the radian mode, otherwise you will get your different answer. So we'll press sine, we'll press 3 divided by, so there is a sine option there, so we'll just press sine 55. We'll get the answer as 3.66, which is equals to 3.66. We'll write it at the 2 decimal places, so we'll have 3.66. So we know that this x value is equals to 3.66. Now we'll do some of the exercise. This example you can do it by your own self. So now, as your exercise homework, I want you all to do this 2 exercises given there. The first, I'll just briefly explain the 2 exercises. So in the question 1, there is a right angle triangle given below. You have to find side x. So we'll use the same operation here. We'll find which side we have to find and which side is given. So we'll just use either so, pa, or toa in that question. And for example 2, for a right angle triangle given A, find the angle x. So this is a very tricky question. We have to find the theta value now. Since both sides is given, so we have to find a theta value. So you will see, I'll just briefly explain which equation to use. Then you can go at home and do it by yourself. So as you know that theta angle is not given, so opposite of theta is your opposite side, and there is a right angle side here. So this will be your adjacent. So you do have your O and A. So O and A is given in toa, so you can use your tangent theta equation. So it will be tan theta equals to O over A. In case, just remember to use sine, the opposite operation for any trig function will be either tangent theta, sine inverse -1, tangent inverse -1, and cos inverse -1. So in your calculator, you can press shift tangent. So it will give you the inverse function, and so by that you can find your angle for that right angle triangle. So if you have any question, please do ask. If not, then thank you.